Perfect. So let's get started very quickly. I think let's not waste any more time because we have another very highly energetic stream coming up right after this. So guys, one more thing before I go any further, let me just introduce what we're going to do in the stream. Let me just talk about what we're going to discuss. What we're going to discuss in the stream. What is the stream about? What is the purpose of this stream? Let's just answer a couple of questions in the chat because there is one particular person who is very eager. Second year, when will start? Hey, Road to 999, we are working very hard on bringing second year content onto the application as well. There have been several thousands of students requesting us. And all of you guys who are first years right now and also studying second years, we are coming to second years very soon. So stay tuned for that. Cynohub is going to be there for second year as well. So right now we are supporting the entirety of first years, and the response that we've been getting from these kind of content and live classes is incredible. So thank you so much for that. So we are going to be there for second years very soon. Thank you so much for asking, and I hope you have the patience till we get things onto track. Hey Shiv Sai Sandeep, lag. I think the lag is sort of it's a lot better now when compared to the beginning. I think this is something comprehensible. Miriche questions iste pass aitama. Lane gamer. Okay. So the purpose of this stream is not to make you pass the exam. This is not what Cynohub does. Cynohub is a online learning platform for B.Tech students built to get you the best amount of marks possible in your exams. Alright, so this is not for something just to get you just above pass marks or something like that. We want to bring you the best amount of quality of education, so you score more than 70 to 80%. Alright, that's the aim and that's the motto of Cynohub. And obviously, one more thing which I want to just say is, if you are aiming for pass marks, then obviously you're going to fail. Aim for 70 or 80 have you heard the saying, if you aim for the stars, you'll end up on the moon, or if you aim for the moon, you'll end up on the stars, something similar to that. So aim for 70-80% and you're going to easily pass the exam. And the best part about all of this is, C programming is not really that hard. C programming is one of the most easiest things once you understand. So the purpose of this live stream is to get you started with C programming. What is C programming? Is it really difficult? How easy it is to learn it? What should you do? What is the mentality or what is the thinking process behind learning C programming? So the aim of this live stream is that once you're done with this stream, you have some amount of knowledge about C programming, and once you sit down to prepare either tonight or tomorrow, which you have before your exam, it's going to sound very similar. It's going to sound super easy, super comprehensible because you attended this live stream. Alright, so before we go any further, I'm going to just wait 30 more seconds. In the 30 more seconds, I just want some response in the chat. So how have your previous exams been? How did you write your mathematics exam? How did you write your physics or chemistry exam? Have the live streams been useful? What can we improve? I just need some feedback in the chat, and based on that, we can quickly start. Alright, so if you can still hear my voice, let's just quickly get some action in the chat. So once you start responding in the chat, I'll quickly start the class. So we're going to learn about C language. Oops, the marker is done. Naini Akhil, very useful, thank you. Physics kuda max pass. I'm glad, lame gamer, that you are going to pass physics, but like I said, if you are a Cynohub student, we don't want you to just pass. We want you to score more than 70 or 80% in your exams. So if you are a Cynohub student, do absolutely aim for that. Alright, so we are going to start C language. Yeah, so before we start once again, a quick reminder. Please do share this video. Please do share this video. Share the link in your WhatsApp groups, Instagram. If you're sharing this on Instagram, do tag us. It's @Cynohub. It's CYNOHUB. And if you're sharing it on WhatsApp, just bring them all in because it's going to be a very important live stream for tomorrow's exam, because a lot of people are struggling with C programming. A lot of requests, C programming is also one of our most requested and most viewed videos on the platform. So C programming is not a difficult subject. That is what I'm here to prove. Alright, so Shivani Anmula, did it start? Yes, Shivani, it's starting exactly at this point in time. You're right on time. Firstly, what is C language? C language is a programming language, alright? It's like you didn't know already. Alright, C language is something, basically let's define what is a programming language before we go any further. C language programming language basically means that, it's a medium to communicate with your computers. It's a medium to communicate with devices, alright? That's programming, or that's programming language. With the help of programming, what you basically do is you give instructions to your PC, to your mobile phone, any of the devices that you have. So how is it relevant to us, or why do we need instructions to give, why do we need to give computers instructions or something like that? Okay, firstly, let us say I'm communicating in English. All right, this is my medium of communication. So Arvind, useful, awesome, thanks. Okay, so I'm not going to look at the chat any longer. So if you guys have questions, just keep asking the questions, and at once I'll kind of address the chat. Okay, so coming to programming languages, what I want to say is, see, I'm speaking in English, you understand English, so that's the medium of communication. So if I speak in Tamil or Telugu or Hindi, you might not understand that particular languages, right? So the common medium of communication for both of us is C language, right? So similarly, the common communication medium for me and my computer is a programming language. Or sorry, the communication medium for me and is English. So the communication medium for me and my computer is a programming language. And in those different types of programming languages, C is one of them. Alright, if you have seen our Instagram video, we talked about why C language is important in 2020. C is a very, very ancient language. It is found in, I guess, 1950s or somewhere at that point in time, but it is still relevant today because the operating systems, Android, Windows, Macintosh, Linux, any operating system that you take has some amount of C language in it at the shell of it. Alright, so if you say this is the entire operating system and this is where you kind of operate, this is a taskbar, something like that, at the core of it, at the shell of the system, C language is being used. Sri Ganesh, syllabus muttam today complete chestara. I wish I could do that, Sri Ganesh, I absolutely wish. But the thing is, we are not going to complete the entire syllabus. What I'm going to do is I'm going to make sure you get a good grip on the subject, and I'm going to make sure that I leave you with enough knowledge that you can learn your subject yourself, or whenever you sit down to learn the subject, it's not going to sound complex. Alright? So firstly, the first thing that we're going to discuss in Unit 1 is primary and secondary memory. Alright, so what is primary memory, what is secondary memory? So just to kind of we give you a quick answer for that. Primary memory is your RAM, alright, random access memory. So in your phone, whenever you're buying a phone, it might be MI 1 plus. Now you see kind of RAM has become sort of a very, very important feature to consider while you're buying your phone, right? So what is RAM? RAM is the kind of the primary memory within the device. So that is a very, very quick memory that is very, very easy to access or very quick to access, and that is kind of your primary memory. Whereas your secondary memory is your storage, your hard disk or the internal storage of your phone or your system, something like that. Alright, it's not visible. Alright, I'll try to write it a little bit even bigger, primary and secondary. Hopefully with what I'm saying, I hope you can comprehend that. Otherwise I'll kind of try to write even bigger. So primary memory and secondary memory, if there is some sort of reference for these in the exam, kind of make sure that primary memory is RAM, because primary memory is RAM, the thing that we have in our phones, remember by that. The secondary memory is the internal storage. Alright, the second thing is compilers. What is a compiler? Compiler itself, the word itself tells you that, compiler, it compiles things, right? So it's like carpenter. What does a carpenter do? It works with wood. Like compiler, it compiles things. So what does it compile? So whenever you want your computer to do something, right? For example, let's just say you're playing a movie, right? For that, you basically what happens is whenever you open a movie file or whenever you open something else, basically behind the scenes a script runs. Alright, there's a piece of code which runs in order for you to watch the movie, or in order for you to read, in order for the computer to read the entire movie file and play it to you, right? So whatever the code that we have, C language, the exact code that we're going to write in a couple of minutes, C language, the code that we're going to write is something that we can read, right? Now, obviously when you send it to the computer, computer needs it in a particular format, 0101. The computer reads in binary format, right? So a compiler, what it does is it takes human readable code to computer readable. This is human, this is computer. Alright? The work of the compiler is that it compiles the code and it makes sure, or it kind of enables the computer to read it. It translates it from human readable to computer readable. Alright, that's the purpose of a compiler. Now, the next thing in your unit is, creating, compiling and executing a program. So this is very self-explanatory. I'll just kind of quickly increase the pace for unit 1 because we have a lot to cover. In the meanwhile, I hope you have a book and a pen with you. If not, please do bring a book and a pen, because a lot of topics that we're going to be discussing, you're not going to remember after the stream unless you note them down. A couple of complex topics, couple of easy topics. And one more thing, if you're finding the stream useful, please do share the link, please do spread the word. Somehow, if you can just share it in your WhatsApp groups or in your Instagram, anything that would be really helpful. All right, creating, compiling and executing the program, that's kind of the life cycle of a function or life cycle of a task, right? So firstly, what you do is you create a program. So you create a program using a language. In our case, we are going to use C language, and you're going to compile this particular program using a compiler. Now that the compiler has compiled the program, and so what are you going to get? So for example, we have this particular piece of code. Now the compiler has compiled, and this is translated into zeros and ones, and then you're going to execute it. So once the code translates itself into something that can be readable by the computer, it kind of it can be executed by the computer, or the computer can kind of follow the instructions that have been given. Okay, so that is a process, creating, compiling and executing a program. The next thing is obviously very important topic. I want you to note this down: algorithms and flowchart. Algorithms and flowchart are one of the most easiest things that you can learn today. Algorithms and flowchart. All right. So algorithms and flowchart, I'm going to quickly go over with a very simple example. Yashwant, I'm trying. Isn't this font visible? I wrote it a lot bigger than what I usually do. As well as if you listen to what I'm saying, I don't think the font really matters, because most of the knowledge is being communicated through audio. So it's just kind of a visual presentation for what I'm doing. All right. So algorithms and flowchart. So let me give you a very quick example so you'll easily understand and you'll keep it in your mind. Okay. Now you have you have a particular task, and you need to write a program for that task. Okay. The task is how to score 80% in your exams. Alright, the task is how to score 80% in your exams. So obviously, if you want to score 80% in your exams, what are you going to do? Firstly, there are a couple of steps that you're going to take, right? Step number 1 is you're going to see if you have all the resources required. So check if you have the resources. If you don't have the resources, go to Cynohub. In Cynohub, you're going to find a couple of lecture notes, study material, something like that. Then you start preparing, then you get 80%. So there is a step-by-step process that you need to do, right? Similarly, for example, whenever you write a program, say a program may be addition of 2 numbers. What are you going to do? Take 2 numbers is the first step. Kind of add these 2 numbers, print these 2 numbers. You want to fill a water bottle. Take a water bottle, fill some water, close the cap. That's a sort of your 3-step or step-by-step process for anything. In this world, if you want to do anything, there is a step-by-step process to it, right? And representing those step-by-step process, you can do it by algorithms and flowchart. And algorithm is one of the easiest things that you can, understand today. Algorithm basically means, you're writing that step-by-step process in English. And I absolutely recommend this process. For example, let's say I want to fill a water bottle, right? Firstly, you have to say, take a water bottle. Once again, I have to write a bit smaller, so you can hear my voice. Take a water bottle. I'm not writing anything cryptic. The next thing, fill it with water. Third thing, close the lid, close the cap. Alright, so algorithm basically means you're going to write the step-by-step, algorithm basically means you're going to write it in a step-by-step process. Alright, so somebody asked me, can tell examples in important examples in algorithms. Okay, so there are not going to be important examples because algorithm is a very general topic. It could be anything, it could be asked anything, right? So for example, I said, right, filling a water bottle, right? There could be any particular thing that that they might be asking. So there are not going to be any important topics in terms of algorithms because it's such a general topic that the question might be on anything, and the solution itself is so easy that you don't even need important topics, right? Similarly, for a flowchart, the same exact thing you're going to do it in a different way. Flowchart. So you're going to start there are different types of symbols that you have to use in terms of representing a flowchart. So let me just quickly show that to you. Alright, so whenever you're kind of like, trying to draw a flowchart, you have to memorize or you have to understand what the symbols mean. Basically, there are different types of symbols in flowchart. One is the start and stop symbol that we can see right here, the green one. The different types of symbols that we have, a small diamond symbol, and I think primarily these. So what do these symbols represent? What do they mean? Kind of like, the triangle represents decision. If conditions, any condition, or if you want kind of like, take a decision, the triangle, the diamond represents that. And these things, they represent some sort of equations if you have any sort of, when we kind of like, give an example, I think it's going to be a lot more easier. For example, let's just say, we need an addition of two numbers flowchart. So once we are done with the unit 1, I think we can quickly ramp up and we can quickly go for unit 2, 3 and 4, because those are the much more important units. But the thing is, with unit 1, it's very easy to kind of like, understand as well as to score a lot of marks in. So I'm going to spend a little bit of time. So like I said, we're going to kind of like, so if you can see, firstly, we're going to start it with a circle. Like I said, the circle represents a start and stop. Then we're going to kind of like take input. Taking input A, input B, kind of like, A plus B is the whole thing that we're trying to do. So for that, we're going to use something called as this trapezoid sort of a thing, not trapezoid. So this is for the input as well as output. Then you're going to do, if you want to do some sort of equation, if you want to perform an action, you're going to use the rectangle. The rectangle is to kind of like, do some action in that. If there is some sort of decision or condition that needs to be kind of like, taken into consideration, you're going to use this one. And once again, you're going to end it with a circle. So whenever you're writing a flowchart, just make sure you're drawing the start and stop, because a lot of people forget that. Alright, so it's nothing but, the algorithm and flowchart are two very simple concepts that kind of like, a representation of a simple task in two different ways. That's just it. Alright, now let's go on to explain the structure of a program. How does an actual C program look? So if you have never seen a C program or if you have never attended a C programming class, then this is going to be very insightful for you. So what does the structure of a C program look like? What does a general C program look like? Firstly, like any other program or like a human body, it has a head and it has a body. All right. So let's just say it has a head and it has a body. All right. So I'm just going to quickly write a simple C program. I think that's going to be that might be helpful. We're going to use #include stdio.h. I know if you don't know anything, this is going to sound a lot complex, but you have to trust and stay with me here. I'm going to explain it very quickly. Int main, and it's going to look something like this. All right. So this is the head of the program and this is the body of the program. So okay, what does the head do and what does the body do? So the body is where the actual program exists. All right. The head is a part where the requirements of the program stay. Okay. So let's just say I'm an athlete. I want to play cricket, right? The body is what plays the cricket, right? The body is what moves. The body is what kind of plays the cricket. But the skill, the decision that I have to take, which kind of drive that I have to hit for which type of ball, the decision happens in the head, right? Similarly for a program, all the action or all the work happens inside the body, but the requirements for that particular piece of work happens in the head. For now, just remember this. As we go further, I'll discuss a lot more about this. All right. The second thing is, this is the kind of structure of a C program, and the header part is called as preprocessor statements. So the second thing is variables. Variables, once again, is a very important concept, because very important concept because any programming language is going to have it. Variable is nothing but something that stores a value, right? Anything that stores a value is a variable. Okay, so why variable? Okay, so if I say something that stores a value, it could be kind of like, picture it as a box. Okay, this is a box that can store some amount of value. Okay, that's a variable. Now, the reason why they call it variable is the value which is being stored can be anything, right? For example, let's just say, oh, box, anything, burger thing. Block. Okay, let's just say I have a particular piece of box, right? Now I have this box, which means this is the variable. Now I want to store some amount of data in the variable. Now the data which I'm storing can vary. The exact name is variable. So now, for example, now I want to store a pen. I'm going to store that. Then later, maybe I want to replace the pen with a small box. I hope it doesn't break. So just like this, the box or the container is going to stay the same, but the value is going to vary, right? The different types of values that we're going to add in this are going to vary. That's the kind of the definition of variable. Whenever, if you're not understanding what variable means, what is kind of the clunky definitions that we have in the textbooks, just understand this. It stores value. The value can vary, hence the variable, right? Now the type of value that we're going to store has a couple of names for it. All right. The first type, it is int. The second is float, double, and string. I think we also have boolean. All right. So what basically int means is that, it's numbers, right? Integers, numbers, just plain old numbers, 1, 3, 5, 7, like that. Float basically means floating point numbers or decimal numbers, 1.4 or 3.6, 5.7, something like that. Double basically means, it's sort of a bigger version of float. Let's just say float can only store this amount of value. Double can store a lot more value than float. All right. String is nothing but our names or the words or sentences that we have. String can be Vamshi. What happened? Not visible. Okay, sorry, this is not visible. I'll just erase it and write it up on the top. String. Right? So string can be names, like Cynohub is a name, Vamshi is a name, something like that. All right. So strings are names. Now boolean, what does boolean mean? Boolean basically means it true or false. All right. So true. So these are different types of things that you can store inside a variable. So inside this one particular piece of box, you can store all these types of things. But before storing these type of things, that you have to mention or you have to declare what type of box it is. All right. So that's how variable works. Now inside this unit, before we end it, we have a couple of two more small topics, just the introduction of those, so that we can understand. The reason why I'm spending a lot of amount of time on unit 1 is because it's kind of the fundamentals, or it's kind of the most essential thing that you need to know in order to understand unit 2, 3, 4 and 5. All right. All right. So we'll quickly go to the last ending topics for unit 1. The other topic is conditional statements. Conditional statements basically means, whenever there is sort of like a dilemma, or whenever you want to have to take a decision, right? The perfect example for that in programming is if and else. All right. So whenever you're writing a program, for example, a very, very simple program might be, grading a student. For example, let us say we want to write a program in which the student has to enter his marks, and if the marks are above a certain number, or the percentage is above a certain number, we want to give him a particular grade, A. All right. For example, let's just say we have to write a program such that a student enters a particular percentage, and if that particular percentage is around above 80%, then we have to give him a grade A. All right. So how do we write a program for this? Firstly, whenever you're writing a program, what I absolutely recommend is try to write an algorithm for this. All right. Try to write an algorithm for a program before you actually attempt a program, because this is going to be very, very crucial, and it's going to play a very, very key and vital role in terms of writing a program. Very, very simply. All right. So firstly, let us say we want to write an algorithm for this particular piece of program. Firstly, we are going to say start, then input a number or input a percentage, Then we are going to check if the percentage is above 80 or not. Check if above 80%. If it is above 80%, give him a grade A. If it is not, just say grade B, I guess. Something like that. And the same exact thing, I'll just repeat it for you because the font might not be visible. Start, input a percentage, check if it is above 80%. If it is above 80%, grade A. If it is not above 80%, grade B, and that's it. Alright. So the same exact thing you're going to, if you have to write a flowchart for this. So this is where, it gets very, very interesting, or this is how flowcharts are actually used. So if you understand this particular process, you can easily tackle the flowcharts that we have. Alright. So firstly, you're going to say start. Then you're going to input something. Right. Input percentage. Then after you take the percentage, what you're going to do is you're going to check, right? So for if conditions, we have this diamond shape, and if it is yes, we have one thing. If it is no, we have one thing. If it is yes, we're going to say grade A. If it is not, then we're going to say grade B. Okay, so then we're obviously going to say stop. Okay, just keep this in mind. So whenever you're writing a program in the program, whenever you're writing your exam, if there is a certain program that they ask you to write, and if it is complex, or if you don't know how to write it, just immediately start writing the algorithm for it, kind of like if you have to. And once you have the algorithm in place, you can easily kind of like, derive the program from it. And the last part of unit 1 is loops. Finally, we are coming in at the end. So like I said, it's very, very crucial that you understand the entire unit, because a lot of the units or all the entire subject is based on only unit 1. So if you understand unit 1, unit 2, 3, 4 and 5 is going to be a lot more easier. Okay, loops. What does a loop mean? Loop is something that you do at continuously, right? Continuously for a fixed number of times. For example, while you might remember in your PT class or in your school or college, your coach used to say kind of like, do 5 rounds all across the ground. So you're going to keep running across the ground 5 different times until it's 5 times, right? So you're going to run for the first time. So we're getting number 1. So number 1 is still less than 5. So you're going to go do another round again. It's going to number 2. Number 2 is still less than 5. So you're going to continue the round again. It's going to be number 3, 4 and 5. Once it is 5, you're going to stop, right? So this is something that internally happens in your brain, and it's very, very simple and easy for us humans. But for a computer, we have to kind of say it specifically that you do these terms, and this is what internally happens with the computer. Okay, and one more small thing that you need to learn is scanf and printf. Scanf and printf. What are these two statements used for? It's basically, in the name itself. Scanf basically means scan. Scan is an input, right? Printf basically means print. Print is an output. So if you want to output something to the user, say printf. If you want to take something from the user, say scanf. So if you want to remember this, think of it as a scanner. We have scanners in our homes, offices. Think of this as a printer, right? So in the unit 1, all you have to remember is what kind of devices that we have. What is an input device, what is an output device, what is the primary memory, what is secondary memory, what is scanf, what is printf, and what are conditional statements, what is a loop, and also one more thing is structure of a C program. What is variables, what are different types of variables, how much memory do these different types occupy, and all of these other things. Alright, unit 1 it looks broad, trust me, it's not. It's very, very basic, it's very, very easy. Algorithms and flowchart absolutely must in terms of exam point of view. So absolutely make sure you're practicing enough of that. Finally, we're done with unit 1. Unit 1 has been for a very long time. Lame gamer lag. Hey, I understand there is some amount of lag with the camera. I understand, my frame rate is not that smooth. But if you concentrate on the board and my voice, I think it should be enough. I do regret that there is some amount of lag, but I think it should be manageable. I hope you guys are able to understand what I'm trying to convey. So if the lag is something that is interfering with the teaching, then just let me know in the comments. Otherwise, we're going to quickly move forward with the class. Perfect. So unit 2, what is unit 2? Unit 2 is very interesting because it sort of builds up on the fundamentals that we already have. So we're going to take a different approach in terms of how we are going to approach the subject. I'm going to approach the subject in a much more, what do you call it, a programmatic language sort of way rather than you know, an exam point of view. Say something about loops, Shreya. Alright Shreya, just if you could stay till the end, I think we'll come back to loops. Guys, in the meantime, if you have any sort of questions, just do leave them in the comment section below. We'll address the comments all at once. Alright, so we'll quickly go to unit 2. So Shreya, I think this unit 2 is going to be really important because in this there are going to be loops involved because arrays, right? So in unit 2 we have arrays. Okay, what is an array? Firstly, let's quickly define what is an array. Array is a string of characters. Alright, so in the different data types that we talked about, in the different types of variables or different types of data that we can store inside a variable, we talked about a couple of things, right? We talked about integer, we talked about strings, we talked about characters, we talked about float, we talked about boolean, etc. So in this, let's pick out character. What is a character? Character is, you know, one alphabet. It is C, it is H, it is C, it is Y, N, just one alphabet. This is a character. Alright, so whenever you're thinking about a character, just remember this. And what is a string? String is a collection of characters. Alright, string, just note this down if this is something useful for you. Collection of characters. Alright, so this is how a string might look like. C, Y, N, O, H, U, B. Alright, name equal to. Okay, so string is a collection of characters or it's a collection of characters, that's it. Right? The other way of representing a string is, I think we deviated from the topic a little bit. We're talking about arrays and in strings. We'll get back to arrays very quickly. Cynohub. Alright, so this is how, there are two different ways of representing a string. Just note these two down. There are two different ways of representing a string, and in this one there's going to be /0. Alright, so /0 is very important for a string at the end. When you're writing it in this form, I don't think /0 is important. Okay, so whenever you're writing it in single quotations or if you're dividing it into multiple segments, then /0 is important. Otherwise, /0 is not important. Okay. So what is an array? Like I said, array is a collection of items, right? Array is a collection of items. It's a sequential collection of items. Thing is, let me give you an example where we might need arrays. Then you might easily understand it. Okay. So coming back to the example of our variable. So now we have a variable, right? So let us say I want to store the names of all the students inside the class. Okay. So for Vamshi, I'm going to use a variable. Alright. So that's one name. Now for another name, I need another box, right? I need to store another box, which is Dheeraj. Then I say, let's say I need another name. So basically in a class we have 60 people. So usually I would need 60 different variables to store 60 different names, right? Instead of that, what if we could store all the names under one variable? How cool, right? So that is array. Okay, so basically what you would do is, let's just say roll numbers. I'll go with a simple example. Int roll numbers, and you would do this. Okay, the square brackets and inside that value represents the size of the array. Okay, so how many values are you going to store inside this one particular variable? In our case, we are going to store 10 values. So this you can represent as this. It can be 1, 2, 25, or some amount of 10 values. All right. So I hope you get the point. So array is, a collection of items. So if you want to store a large collection of items under one single variable, then you're going to use array. So now that we have array, what is a multi-dimensional array? So generally, this can be of any particular format before we go into multi-dimensional arrays. So this is for int. You can have character array, and you can also have boolean array. We can also have float array. So multiple different types of arrays. And this is how, what we discussed about is going to be very, very easy. The string is going to come back. The string which we talked about earlier is an array of characters. Alright, so if you remember, the string is just nothing but it's a sequence of characters, right? It's an array of characters. That's just a string. Okay, so just note these things down because these are very, very important. String is something that we have to discuss, but now that we're already in this particular topic, let's continue with the flow. Now, what is a multi-dimensional array? The thing is, guys, with C programming, especially since it's a sequential subject, when I say it's a sequential subject, everything builds upon the other, right? So we have one piece of fundamental, then we have another piece of fundamental, which you can understand only if you know this. Then there's something else which you can understand only if you know this. So even if you get important questions, it's going to be very, very difficult for you to understand how to learn those questions. So that's the reason we're kind of like, going for all sort of, a brief explanation about the entire topic. So lame gamer, what I'm doing is while we are going to like, going through the entire subject, I'm pointing out certain topics which are very, very important. So if you note these things down, if you kind of like maintain a clear log of what we're discussing here. So whenever you're preparing for your exam, it's going to look like a lot more easier exam than it usually is. Okay, so multi-dimensional arrays. What is multi-dimensional? Multi-dimensional basically means, consider a matrix, right? So how does a matrix look like? It's going to look something like this, right? 1 0 0 0 1 0 1 0 0 1, something like that. So this is a general format of a matrix. So if you want to represent this matrix, it is a 3 by 3 matrix, right? 3 into 3. So if you want to represent this sort of matrix in C programming, you're going to use a multi-dimensional array. So inside this matrix, all the values are integers, ones and zeros, all the values are integers. So what we're going to do is we're going to do this. We are going to say int matrix. Once again, this is just the name of the variable. It can be anything. It's up to your choice, whatever you want to name it. And we're going to give it the size, which is 3 into 3, which technically is 9. 1, 2, 3, 4, 5, 6, 7, 9. Okay. And inside this, we can just quickly represent the values. Alright, I hope you understand. So that is nothing but multi-dimensional arrays. Multi-dimensional arrays are, to store. Multi-dimensional arrays are nothing but, to store these sort of, matrix type values in your C programming. Alright, so let's just address the chat very, very quickly. Hey Ardeep, asle time ledu ante antela story cheptunnava enti. Hey Ardeep, you can leave the stream. Thank you so much for coming in. You can absolutely leave the stream, and I hope you had fun up until now. So you can leave the stream if you are not enjoying the stream. But for everybody else, I hope you are finding the stream entertaining. So let's continue with the class. Perfect. So going forward, let's just go to strings, right? What is a string? Srividya, guys, there are a couple. Okay, let's not address them. Perfect. Let's go forward. So let's go to strings. Like we talked about earlier. So strings are nothing but an array of characters, right? So let's if it's an array of characters, what can we do with strings? So let's just quickly give you a quick syntax of what a string looks like. So let's just say we have a name. So we talked about the syntax. It's C, Y, N, O, H, U, B, right? So in a string we have multiple characters. So like I said, it's a sequence of characters. And one thing you absolutely have to note is, whenever you're ending a string, you absolutely need to include this particular character. Let me write it a little bit bigger. It's backslash and 0, right? You absolutely have to include this character because if you don't add this, because if you do not add this sort of character at the end, it's going to be very difficult for the computer program to understand where the string has ended, right? This is kind of like, your full stop for your statement, something like that. So whenever you're writing a string, absolutely do not forget. Or the other way of representing a string is through double quotes, and you can just say perfect. So that's how you represent a string. Now, see, what C language usually does is it gives you a lot of really cool and nifty tricks or really cool functions which you can do a lot of other stuff with the strings. For example, this is very, very important. This is a really important topic. This might come up in the exam. So just listen to this very, very carefully. Let us say if you want to find the length of the string. All right. Now, there are two ways you can do this. Finding the length of the strings. The usual way, or the one way which we know up until now, is by using loops. So, like I said, what we can do is we can keep on continue to kind of iterate through the string, and we can continue each and every single value that we have, like 1, 2, 3, 4, 5, 6, 7. Now, since it's a small string, it's going to be really easy. But if it's a huge and lengthy string, it's going to be very difficult. Hence, C language provides us with a cool, real nifty function called as strlen. Alright, so strlen basically means string length. So with the help of this function, what you can do is you can quickly find out the length of the string. The second thing is strcpy. So these are some string functions that you absolutely have to remember, because these are very, very important. So these these four functions that we have are very, very important. These might come up in your exam. So strlen is string length. Then we have strcpy, which basically means string copy. Let's just say we have two different strings. One string is A, that just says Cynohub. Let's just say we have another string. Yeah, that's what I'm doing. So the second string is engineering. Alright, so let's just say I want to copy one string into another string, or let's just say the first initial string is just blank. Alright, let's just say I want to copy this into this. So what we're going to do is we can just say strcpy A, comma B. Alright, so C language is basically helping us at this point in time. So kind of like, to easily and quickly copy things or do string manipulation functions. So strcpy is also very, very important. If possible, kind of like, try to write a program on it. Try to kind of like practice a little bit more programs on this. The next thing is str. This is an interesting thing, because str is also very, very important. So like I said, these four functions are very, very important, not only in terms of your exam, but also in terms of the general C language perspective. So listen very, very carefully, because if it appears in your exam, you should be able to write it. Okay, str basically means to find a string inside another string. Okay, to give it a very quick example, let's just say we have one string saying Cynohub Btech. Okay. The second string saying Btech. Now, let us say if we want to find if Btech or this particular set of characters is in this one. So usually, if we have to do that, we have to write a for loop. We kind of like have to check each individual character, and we just kind of like have to maintain multiple variables and something like that. But instead, what we can do is we can use something called as str. In the brackets, we can just say A, comma B, and this will do all the hard work for us. It's going to kind of like sit down, go through the entire two strings, and it's going to tell us if these two strings, if the second string is available in the first string. All right. So once again, make sure you have these things written down: strlen, strcpy, str, and one more thing is strcat, string concatenation. This is very, very easy and also very, very important. So if you want to understand this one, I kind of just pay attention for just 30 seconds. I'm going to very, very quickly explain it. Concatenation, this word is nothing but addition. Concatenation. Alright, This is nothing but addition, which means joining two strings. Let's just say A, we have a string called as Cynohub. Let's just say B, which we have a string called as Btech. Alright, string concatenation basically if strcat A comma B, then what we're going to get is we're going to get Cynohub Btech. Right? So if you want to add two strings, once again, this is sort of like the easiest way to do so. C language provides us with sort of these simple nifty tricks that we can really use to kind of like quickly write programs instead of writing heavy big loops and all that stuff. So do remember these things: strcat, strlen, strcpy. All right. So once this is done, a majority of your unit 2 is going to focus on these things. Then we can also have array of strings. So we talked about what are arrays. We talked about what are strings. We're going to talk about array of strings. So array of strings basically means, I hope you understand just by the name of it. So it's an array which is containing multiple strings. Strings are once again an array of characters, right? So it's kind of like inception sort of a thing. So let's just say we have a set of names. Right? So we talked about we have a set of names. So that example is going to look something like this. Character, names, and this is going to be an array of names. Alright, so in this we can say alright, so these three strings are inside an array called as names, right? So for that, just for that case, so the number of strings and the length of each string. Alright, so that's how a multi-dimensional array is kind of like structured. So if you just go through the multi-dimensional arrays in a little bit, you're going to easily understand how to sort of write these sort of multiple arrays or multi-dimensional arrays programs. So Dinesh, can you say which to study first? So Dinesh, like I said, this is the if you want to really understand C programming, or this is not like other subjects, So for example, if you have a subject like physics or chemistry or some other subject like mathematics, Unit 1 is not basically connected to Unit 2, or Unit 2 is not connected to Unit 3. So you can start from anywhere, or you can kind of like, plug your answers in from any other unit. But what C language usually is, it's a sequential subject. Without understanding Unit 1, you're not going to understand anything. Without understanding Unit 2, you're not going to understand Unit 3. Without understanding Unit 3, you're not going to understand Unit 4, and so on and so forth, right? So that's the reason we have to come in sequentially. We have like no other choice. And coming to important topics, like I said, I'm mentioning it before before the topic that we're discussing, if it's important or not. So kindly note them down while you're kind of like, listening. Okay. So we'll take a quick 1 minute break, and then we'll be absolutely right back for the structures. Alright, so we'll quickly get started. So since we're running out of time, so we'll just increase the pace up a little bit more. Okay, so the next topic is structures. What is structure? A structure basically means, it's a collection of different things stored under one variable. So, okay, so you might be confused with what is structure and what is an array, right? So both of these have some similar amount of definitions. Okay, so what array basically means is collection of things which are of same data type. It can be collection of integers, it can be collection of float, it can be collection of strings, so on and so forth. But what a structure is, it's a collection of things of different data types. For example, let's just say I want to create a variable of a student, and inside that student I want to store sort of his name, his marks, and kind of his section, his branch, his year, something like that. So usually what I would do, so I would have to declare 4 to 5 different number of variables containing each different type of value. One variable for name, one variable for branch, one variable for year, one variable for semester, and something, so on and so forth. But instead what you can do is, and referencing them throughout the program is also going to be difficult, but instead with the help of structure what you can do is, you can create a variable, your own variable, the format or the syntax for that is struct, 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 the name of the structure that you want to create, structure student. Inside the student, you're going to write down the list of things that you want to store, right? For the first thing is character array of name, okay, and you also want to store integer roll number, integer semester, integer year, something like this, right? So if you do this, then what you can do is you can create a student based on this structure. Okay, so this structure concept is very, very important, because if you are a CSE student, as you go forward, this structure concept or this basic concept, an object, it's going to come back in your Java or in your Python or wherever you go. So absolutely make sure you understand what a structure means. So like I said, structure is a collection of things of different data types. All right. So this one structure has collection of different data types. So for example, now that we have this structure, let's just say I want to create a structure for one particular student. Okay. So how I'm going to do that is say struct uct student, which is the name of the structure, which basically means, it's going to draw the exact same format onto it, and the name of the student. All right. So then we can easily say the name is obviously, Vamshi. The semester is 2, and the kind of the year is also 2 or one, something like that. Okay. So the advantage that we get is we are able to kind of define, or we are able to create multiple variables based on our liking and based on our sort of way of defining things very, very quickly and very, very easily. So that's the use of structures. So while you're preparing for structures, just keep these things in mind. Structure is nothing but a collection of things of different data types. So once you know that, it's going to be very, very easy to kind of understand what structures are used, understand how these things are kind of useful in our day-to-day lives. Now you might be wondering, if you're not wondering, let me just put a thought in your head that for structures, let's just say, now that we defined one student, right? Now we have a class full of students. Let's just say we have around 60 different students. Now, for these 60 different students, now obviously you cannot once again define 60 different structures, right? So instead, what you're going to do is you're going to have something called as an array of structures. Does it make sense? Once again, array is nothing but collection of things of same data type, whereas structure is collection of things of different data types. So that's kind of the idea behind what the structure is. The next major important topic is pointers. So absolutely make sure you understand what a pointer is, because pointer is going to be something that is going to be very, very critical in terms of C language. All right. So let me give you the most simplest explanation of a pointer. The pointer basically means it's an address of the variable. It points to the address of the variable. Okay. Let's just say we have something like int age is equal to 45. Okay. We have an age. Now, this is the actual value. Now this value is going to be stored somewhere on your computer, right? So whenever you declare a value, what basically C program does, or what basically compiler does is, so it's going to need to store this value in some place at your computer. So that place has an address. Just like how you and I live in our homes and how our homes have an address, all these variables have an address. All right. So pointer is something that's going to point to this address. That's it. It's that simple. So the advantage of having a pointer is, whenever somebody changes the value, instead of kind of directly changing with the variable, they can change the value at the address. Then the value is automatically going to be changed. All right. So this is going to be very, very useful, in a case where a lot of variables have the same value, right? For example, let's just say semester or kind of roll number. if we kind of like, say, if we say, 3 to 4 different variables have the same exact value and you want to change the values of all these 3 variables at once, these three variables should be pointing to an address. Alright, instead of giving them actual value, you can actually give them an address. And you're going to declare pointers using a star mark P or star mark anything. The P is just the name of the variable. Star mark age, which basically means the address of that variable age. Alright, so pointer is once again very, very important. It's going to be super, super useful in terms of learning as you progress C language. So make sure you understand what a pointer is, make sure you understand the concept of pointers, because one thing in terms of exams perspective, I think it's going to be definitely something that you can expect in your exams. So that's for Unit 2. Once again, Unit 2 is a little bit shorter than Unit 1. Like I said, as we go further, the units are going to get shorter and shorter, quicker and quicker. So Unit 1 is very, very big. It's kind of like, the introduction for all of these topics, introduction to the entire fundamentals of the subject. But Unit 2 is kind of something that builds upon this. So to quickly recap in Unit 2, and you need to understand what is one-dimensional array. You need to understand what is multi-dimensional arrays, because these are something that is going to be very, very important. And I think addition of multi-dimensional arrays could be something that could be asked. Addition or subtraction or multiplication, once again, these are very, very simple to understand. Once you understand the concept of how to access or how to create a multi-dimensional array, it's going to be very, very simple. Then you have, in terms of strings, you have to absolutely remember string length, string copy, string concatenation, and strings str, string compare. And you have to kind of sit down, look at array of strings, also structures, what structure is, array of structures. So if you understand what these things are, if you understand how to declare these things, how to use these things, and what is the purpose of these things existing in terms of the C language in general, you're going to be able to easily understand what the subject is entirely about. Okay, so in terms of Unit 3, let's do one thing. Let's discuss the first part of Unit 3 now, and let's discuss the second part of Unit 3 at a later point in time, because the way the C language should be structured is kind of like, in that particular aspect. So it's going to make a lot of sense if I discuss it at the end. So we'll go to Unit 3 quickly. So we have only 3 more units. We're going to wrap it up very, very quickly. Subject, hopefully it's getting interesting as we go forward. So in Unit 3, there is this thing called as preprocessors. Preprocessor directives or preprocessors basically. Okay, so in order to understand this, let's quickly flash back to Unit 1. In Unit 1, we talked about a structure of a C program, right? It has a head and it has a body, if you remember this diagram. It has a head and it has a body. So in terms of defining a program, what did we say? The entire work is done by the body, but the entire skill set is going to be staying in the head. So preprocessors are the skill set, alright? Preprocessors are basically the superpowers you give to your program. So it can be useful for in terms of doing the task that we give. For example, in terms of if you want to print something or if you want to take an input from the user, the input and output, for that you're going to use a preprocessor called as stdio.h. And that you're going to do it by saying #include stdio.h. Alright, so this is a preprocessor. It basically means preprocessors. It processes pre-processing. It does it before something else. So once #include stdio.h basically is written, stdio basically means standard input output header file. So what this basically does is it gives your program the ability to kind of print things or take things as an input. Alright. So #include stdio.h. So you might have seen this kind of line in terms of a lot of programs. It's kind of like a must for almost all programs at this point in time. There is also one more preprocessor directive called as #include math.h. What #include math.h basically means is that it's going to give your program the capability to do mathematical operations, not just a simple multiplication subtraction, but if you want to do the power of something or if you want to calculate the square root of something, then you can use the math.h to very easily do those things. All right. So once you have these superpowers involved, or once you have these superpowers embedded into your program, you can write the particular functions, or you can use these powers to kind of like define your body of the program. Alright, So for example, let's just say if there is a program that says take an input from a user, take a number from the user and print out the square root of it, or print out the square root of it. So then you're going to do both of these. You're going to, for the input as well as printing input and output, you're going to use the stdio.h. Then in terms of calculating the square root of it, you're going to use the math.h. Alright? So that is a preprocessor directive. And there's one more thing called as hash define that you need to understand. So guys, if you have any sort of questions, just keep leaving them in the comment section below, and we'll sort of answer all the questions at once. So hash define. Alright, so what hash define basically means is that, it gives out sort of, it is used to declare a constant. Constant basically means, a variable or, a value that does not change throughout the entire program, right? For example, a student's name is not going to change, right? That value can be a constant. But if you think the student's name is going to change, let's just pick one thing. What can be that one thing that cannot be changed? Let's just say a formula. A formula is something that doesn't change usually. Okay, so you can declare it as, formula. It can be a string or something like that. Just square. Okay, so for hash define basically means you're going to define a particular variable that is not going to change at any point in the program, right? You will not be able to change this particular piece of value, right? Because it is defined. This basically means that, formula is basically defined as this one. It's a definition. You don't change definitions in midterms, in mid-program. So this is something that you have to remember in terms of pre-processing directives as well as hash define. So as you kind of write programs on a day-to-day basis, it's going to be very, very easy or very, very understandable how to kind of write these sort of programs or where these things are actually involved in. So we'll quickly move on to Unit 4, and like I said, we'll come back to Unit 3 at the end once again. So Unit 4 is functions, and from here on out, it's going to be mostly about your logical thinking or your logical reasoning. So that is going to be heavily dependent upon this two units, Unit 4 and Unit 5. So the main thing with Unit 4 and Unit 5 is that, now that we have all the fundamentals in our mind, now that we have all the things that are going to be required for this C language subject, let's just discuss how we can use to kind of write actual programs. So Unit 4. So what does a function basically mean? A function basically means it's a set of instructions. Alright, just note this down. This is also very, very important. Function basically means it's a set of instructions. Alright, so what is the use of functions? A function is basically used to kind of keep your code clean, as well as to segment your code into multiple bits and pieces so that it is easy to maintain. Okay, so I'll give you a quick example. Let's just say I want to add two numbers. Okay, that's a very lame example, it's a very simple example, but let's just say that is the case. Alright, so we're going to declare two variables. Now we want to add those two variables. Usually what you would do is you are going to declare another variable. You're going to say c equal to a plus b. Then you're going to say printf c, or you're going to say %d c. Alright. So with this you're printing the thing. This is the entire very simple program. So now this is the main thing that we have inside the program. That is the meat of our program. Now let's just say I want to kind of isolate this part, or let's just say this part itself is around 10 different lines long, right? So let's just say not only we want to add the entire thing, but we want to take an average of it, and we want to kind of do a half of it, something. There's a 3-4 different step process. Let's just say it is okay. So now having the entire logic of your program within your program is going to be difficult to maintain. As your program goes bigger and bigger, it's going to be very difficult to maintain. So instead what you can do is you can isolate this piece of code into a different function, right? So you have to declare a function that is c, let's just say add. let's just say the numbers that you're going to be passing, a comma b, and you're going to say add a comma b, return a plus b. Okay, so let me just quickly go over what we did here. So int add a comma b, what is this? We're declaring a function, alright? So function, like I said, it's a piece or it's a set of instructions, okay? So it is a set of instructions, that's a function. Now in this set of instructions, sorry if you're copying it down, it's just very simple, I don't think that's really necessary. Just listen to what I'm saying and I think the concept should be pretty much clear. Okay, it's a set of instructions. Now you need to understand what does it return. So function, how do I define it? Let's just say it's kind of like, your Zomato order or your delivery person. So what you're going to do is you're going to give a set of instructions to your delivery person. You're going to say, go to X place, go to Paradise Biryani. You're going to say, take the order, which is biryani. You're going to say, come back and give me the order. Alright, there are 3 different steps that you have in that particular instruction, in that set of instructions. So what you can do is, inside the function, you can give that 3 different steps. Place order or something like that, or just say order. And inside the order or inside the function, you're going to give out a couple of instructions or a set of details for that particular function. Like the place, in our case it is Paradise, and in the end, the food item. In our case, it's biryani. Alright. So when the function executes, when the function starts, so it knows what is the place, it knows what is the item. Now what should it do? It has to return you something. It has to return you a value, or it has to return you a package, right? Similarly, in our add 2 numbers function, we are going to say add, and we are going to give it 2 numbers, 1 and 2, and it's going to take these 2 numbers and it's going to return a value, right? It's going to return the addition of these 2 numbers, which is 3. And this 3 is an integer. You get what I'm saying? So that's how, if you want to define a function, you have to firstly tell the computer what it is going to return. In our case, it is integer add, the value a comma b. Just giving an indication that, these are sort of it's expecting 2 different variables from an external party. Alright. So inside the addition function, then obviously you're going to add these 2 variables and you're going to return that variable to the main function. Okay. So inside the main function, you're going to call this, yes, you're going to say add 1, 3 or something like that. It's going to give you back 4. Okay, so to quickly, I don't think it's that concept itself is so complex that I have to write an entire program for it. So I hope it's clear enough. So if it's not clear enough, just do leave a small comment in the comment section and we'll get back to that. So basically, yeah, functions. Functions is a set of instructions, you need to know that. So while you're declaring a function, you absolutely have to mention what kind of value it returns. So based on that, the set of instructions inside the function is going to work on. And that's sort of the main primary thing of functions. Now inside a function, there are 2 different things. Alright. So calling a function or sending a value to the function is mainly 2 different things. It call by value and call by reference. Okay, so this once again important, very very important. So call by value and call by reference, it's not only important in terms of functions, it's also very very important in terms of the entire C language. So if you are looking for something in terms of the exam perspective, call by value and call by reference is once again very very important. So we're going to quickly discuss about what these things are, what is call by value and what is call by reference. Alright. So call by value and call by reference basically means, how are you passing those instructions to your function? So let's just say quickly the thing that we discussed earlier, the example that we discussed earlier, the addition function, right? Let's just say we have an addition function and we're giving in 2 variables for it in order to add a plus b or one second. So let me just give you even better context for this, so you'll be able to understand a lot more better. So let's just say we have a program of swapping two numbers. I think this is the better context for that. So let's just say we have a program for swapping two numbers. So how are you going to write the numbers? So obviously, since it includes an input as well as output, we are obviously going to include #include stdio.h. It's a header file, standard input output. That's obviously required at this point in time. Then you're going to do an int main. It's an open bracket. Inside the main function, let's just say we have two variables, int a equal to 10, int b equal to 30. Obviously, once again, one small disclaimer, whenever you're writing your program, after each and every single sentence, do not forget the semicolon, alright? Absolutely remember to write the semicolon, because it's going to be very, very important. Otherwise, your program is not going to execute at the same time. The evaluator, if he sees that, is going to cut your marks. So absolutely make sure you're writing the semicolon after each and every single statement. Okay, now you want to swap these two numbers. You want to kind of like, get your value to 30, a value to 30, b value to 10. So you're going to pass these two numbers into a function, right? So you're going to say swap a comma b, and so you're also going to define the swap. It's going to take an int. It's going to say swap a comma b. Is it visible? Yeah, it's visible. So I won't go any further than this. I'll just stay here. So what it does is, so inside this you're going to write the code for swapping those two numbers, right? So a should be, this is not the code. So you'll be writing some code to kind of like, swap the two numbers. Oops. 1 second. Yeah, you would be writing some amount of code kind of to swap the two numbers. Now here is where you're going to understand what is passed by value and what is passed by reference. Alright, so this is the reason why we're coming in gradually. Alright, so you're going to understand it very, very quickly. So now what we're doing is we're passing a value to these functions. Okay, we're passing the value a, we're passing the value b. Okay, so when we do this, what usually happens is it sends a copy of the value to the function. It does not send the actual value, it sends a copy of the value to the function, which means it's going to create a small copy of the value 10 and it's going to send here. It's going to create a small value of the copy 30 and it's going to send here. It's not going to send value A, it's not going to send value B, it's just going to send the copy of the value. Alright? So the problem with this is, if you do this and if you kind of swap the values at this particular function, the resultant variables here are not going to change, because only a copy of them have been sent. The originals remain the same here. Alright, so even after we do swap a comma b, if I'm to print a comma b, the values would still remain the same. I'm going to show you a quick program on the computer as well. So before I do that, I just want to kind of finish the entire theory of it. So this is passing by value, which means you're going to just send a copy of the value to the function. Now the second best thing is pass by reference. Now each of these two things have certain places in their own kind of respective contexts. But in terms of passing by reference, what basically means is that for that swap function that you wrote, you're going to send in the addresses of those two variables. Alright, such that anything that you do or any change that you make gets directly reflected to these addresses of that value. Okay, so now if a becomes 30, this 30 value is going to be reflected here, and throughout the entire code it's going to be like a is equal to 30 after that function. Alright, so in terms of passing, so this is once again, it's a pointer. That's the reason we took that long in terms of discussing about pointers. So that is also one of the reasons why we have to come in sequentially in terms of learning C programming. This is not a subject that you can learn from the middle or kind of go to the end or just talk about important topics and just leave. This is something that you absolutely have to gradually learn or gradually come up with. Alright. So like I said, pass by value, pass by reference. Two very, very important topics you need to understand. Pass by value basically means it sends a copy of the value. Pass by reference basically means it sends a reference or the address of that variable. So in terms of reference, the original values are also going to be changed. In terms of value, the original values are not going to be changed. Alright, so if it comes up in your exam, make sure you're writing these points very, very clearly. So this is pass by value and pass by reference. Once again, very, very important. And at the closing of unit 4, we have two more things, super important. One main concept is recursion. Recursion, if you don't understand the concept, it's a bit complex, but once you understand it, it's going to be very, very simple. We're also going to see a very, very quick example of how to kind of calculate the factorial as well as kind of the Fibonacci series, which are two very, very important programs that might appear in your tomorrow's day after tomorrow's exam. Okay, so first, what is recursion? Recursion basically means a function calling itself. That is recursion. See, once again, we have to refer to functions. If we could have skipped any part of either, which is unit 3 or unit 4, if we did not discuss what is functions in unit 4, we would not even know what recursion is. Alright, it's a concept that builds upon its previous concepts. So, a recursion basically means a function that calls itself. Alright, so how does it work? Why is this concept even involved? So, in recursion, you have to kind of remember a couple of things. If a function is calling itself, there has to be a break for it. If there is no break, it becomes like an infinite loop and it keeps on running forever. Okay, so whenever you're writing your programs, make sure you're not writing infinite loops. So, in terms of recursion, what you also need to understand is it's basically like a loop. Alright, instead of for loop, instead of while loop, instead of do while, you can also write recursions. So, how does recursion help? In terms of functions, so whenever you want to kind of repeat the execution of the function multiple times, kind of it's the same exact code that you need to run a lot of times, then you can use recursion. So I'm just going to quickly give you an example of what recursion is. Or if we are not able to get it, let's just search for it. Yeah, say program for swap of numbers. Yeah, we'll also discuss the swap of numbers. It's very, very simple. Once you understand how it works, I think it's not that difficult. We'll just discuss that as well. Alright, I hope you can see. What I'll do is, it visible now? Yeah, it's visible. Okay, so in this, the factorial, basically let's discuss about what factorial is so that we can understand what the function basically is talking about. So factorial, like I said, is very important, so make sure you're not missing out this one. Let's say we are trying to find out 5 factorial, right? So if you want to find out 5 factorial, what does it basically means? It means 5 into 4 into 3 into 2 into 1, right? What is the formula? It is n into n minus 1 into kind of n minus 1 minus 1 and so on up until the ending part up until 1, right? So this is the formula for factorial. Basically we can do this with a for loop, but if you want to do it with recursion, it's going to look something like this. So here we have a function, multiply numbers. This is a function and we're sending it a value of n, right? Which means we're sending it an integer value. And then we just declare the function here. Then we're going inside the main function. Inside the main function, we're declaring another variable, which is also n. And we're asking the user to enter a positive integer. So here is the scanf. So I don't think we discussed an example for scanf, but this is a very, very simple example. So you're going to just say %d, which is the kind of integer, and way to store this particular value that user enters, you're going to store it in this particular variable n. Alright. So, and print the factorial of the number basically n, and by using this particular function. Okay. So how does it work? So let's just say into this function, multiply numbers, we sent in an integer of 5, right? So we sent in an integer of 5. Oops. Yeah, We sent in an integer of 5. Now the first thing what the function is going to do is it's going to check if the 5 is less than or equal to 1, because remember the factorial, we have to end at 1, right? So it's going to check if 5 is less than or equal to 1. So if it is not, or if it is less than or equal to 1, which means it's the end of the program, it's just going to say the n into multiply numbers or into my n minus 1. Yeah, so n into multiply numbers n minus 1, which basically means it's going to say that oh sorry, one second. If n is greater than or equal to 1, which means it's not equal to 1. If n is greater than 1, which means it's just still in the stage of 5 or 4 or 3 or 2 or 1. So then what we're going to do is we're going to have to repeat the entire process, which means n, which basically means 5 into multiply numbers n minus 1, which essentially becomes 4. N minus 1 becomes 4, and inside this 4 you get 4 into multiply numbers 3 into 1, and inside the 3 into 2 into 1. So it kind of like loops itself. So this is nothing but a function calling itself. So see how we are calling multiply numbers in itself. And remember the point where I said you have to make sure that you don't write infinite loops. This is the break point. If n is not greater than or equal to 1, if the condition is not met, then you're just going to return 1. Alright. So essentially when this program is running, what basically happens is we are going to get 5 into 4 into 3 into 2 into 1. Alright. So recursion basically works like that. It's kind of like a function calling itself. So once again, I'm just going to quickly repeat what it basically means. Inside the recursion, we are going to take an integer value or any value for that matter. So we're going to just take an integer in this case because we're discussing about the factorial of this number. And that particular number, whatever it is, we're going to check if it is greater than or equal to 1, because factorial basically ends at 1, right? So if it is greater than 1, then we're going to say n into, which basically means 5 into multiply numbers by 4. N minus 1, which is basically 4. Then the entire process comes back and this kind of like, creates an loop inside loop inside loop inside a loop inside a loop. So essentially what basically happens is n into 4 into 5 into 4 into 3 into 2 into 1. Alright. So that is the factorial using recursion. So absolutely make sure you have this program set up, because it is very important. What is return 1? Return 1 basically means send back 1, right? If it is not, if for example in this case, if 5 is greater than 1, yes, it is greater. So we are going to return this one. Return basically means what is the value that we are going to send back to this printf statement, because this is where we called in the factorial, right? So in this factorial, whenever we call this function, we need a value that the function is going to return. And if you remember, if we go up a little bit, we declared that the function is an int, which means it's going to return an integer. So the function needs to return an integer, and in this case it's going to multiply the entire set of numbers and it's going to return an integer if the number is greater than 1. But if the number is not greater than 1, which means we have reached the end of the program, we are going to return just the value integer 1. Alright, very important, super important. Kindly note this down, very important, factorial of a number. The next thing is Fibonacci series. Fibonacci is very interesting. So you need to, once you understand how to write these programs without using recursion, then I think using recursion is going to be something very simple. So once again, in unit 4, these two topics are very important, recursion and factorial. Sorry, factorial is done. Now we're going to talk about Fibonacci. Okay, so Fibonacci basically means the series itself is very simple: 0, 1, 1, 2, 3, 5, 8. So how is this working? So Fibonacci basically means A plus B is going to result to C, and for this plus this is going to result to this. 1 plus 2 is going to give 3. 2 plus 3 is going to give 5. 3 plus 5 is going to give 8. All right. So even for this, it's going to be a very simple program. If you just understand how to kind of write the this is sort of like the the way the Fibonacci series or the way the recursion works. Just have a look at this. Yeah. So the biggest advantage of recursion is that it reduces a lot of code that we have to write. Generally for loops or whenever we're trying to write loops, it basically takes in a lot of different set of instructions. But instead whenever you're talking about recursion, in a couple of lines we get the same exact functionality. Though a bit complex, very efficient to write and also very efficient kind of to execute. So in terms of unit 4, that's it. Very simple. So if you understand factorial, you have to understand what is recursion. Inside recursion, you just go over what is a factorial, what is Fibonacci series. Then before that, you have to understand the functions. The functions part, like I said, functions, set of instructions, call by value, call by reference, two more very important things. Then quickly we'll just go to the final unit, unit 5. Unit 5, there's not going to be much to talk about. Very simple unit, easy to score, easy to understand as well. Algorithms. The entire unit is based on your understanding of C programming. Alright, if you understand C programming well, if there is something that if you are able to write programs on by your own, unit 5 is something that you can easily kind of crack the entire thing. Okay, so first part consists of quadratic equations, finding the minimum value or finding the maximum value, or finding if the number is prime. Something like that. Just simple programs that is going to help you kind of to identify how to write that, to kind of strengthen your basics in C programming. Okay, so we'll quickly discuss about how to tackle these sort of programs if they appear in your exams. Okay, so firstly, let's just say we are going to say how to identify if the number is prime or not. The way you identify so if a program like this comes in your exam, what you have to do is you have to write an algorithm for that first. Okay, so what is the algorithm like? So first thing you have to say start. The second thing you're going to say is if the number is divisible by 2 or itself, by 1 or itself. So if the number is divisible by 1 or itself, then it's a prime number. Otherwise, if it's divisible by any other number than 1 or itself, it's not a prime number, right? So this is a condition. So if loop. So very simple. If you just write an algorithm for this, it's going to be very easy for you to convert this or translate this into code. So you start, you say int main, you just take a number, you're going to write an if loop, you're going to say if the number is divide percentile of, or if you're going to write a for loop, which basically means, for example, if you are testing if 7 is a prime number or not. So what you're going to do is you're going to divide the sequence of numbers with 7. For example, 7 percentile of 1, 7 percentile of 2. If the 7 percentile of 1 is 0 and 7 percentile of 7 is 0, which means when you divide 7 by 1, the remainder is 0. When you divide 7 by 7, the remainder is 0. For rest of all, the remainder is going to be 1. So in these two cases, if these two cases dividing by 1 and dividing by itself is 0, then we say the number is prime, right? So for this, you just have to go through 0, 1, 2, 3, 4 and so on and so forth. Sorry, 1, 2, 3, 4 and so on and so forth. So for that, you have to write a loop. So inside the loop, you have to have an if condition, and inside the if condition, you just have to check two different conditions. If the number, sorry, one condition, if the number is divisible, if divisible by that particular number, then you can just easily, quickly come back and say if the number is prime number or not. All right. So anytime such a program or such a kind of question appears, write an algorithm for it, and then it's going to be very easy for you. So similarly for the maximum as well as minimum value, as well as for the quadratic expressions. So for the quadratic equations are something that is going to be very easy for you if you just go over the couple of sums that are given for you. Quadratic equations, you just have to kind of understand a way to represent these formulas in terms of code. That's just it. So very quickly, we'll end the entire live stream by discussing searching and sorting. So I understand this is a very long class, but that's sort of the nature of C programming. Without understanding the multiple concepts, it's going to be very difficult for you to prepare or guess the important topics in terms of this particular subject. So searching, we have two different types of searches. So one is linear search, one is binary search. So I'm going to quickly explain you how these two things work, and I'm going to show you a quick animation of how these two things work. Then hopefully when you see an example problem, you're going to be able to understand how it works a lot more easier. So how does a linear search work? Just like the name, right? So let's just say we have a sequence of numbers. Let's say we have 5, 15, 23, 57, 70. Now I want to find 23, okay? So what linear search does is, let's say we want to find 23. It's going to compare each number with the number that we're trying to find. It's going to compare 1 with 23. Is it same? No. 5, it's the same? No. 15. Up until it reaches the actual number, alright? It searches in a linear fashion. It searches one by one by one, alright? The biggest disadvantage is it's very, very time taking if the number is kind of like, sort of at the end or something like that. But for this, we have another solution which is called as binary search, which is very, very interesting. Let's just say we have the same amount of numbers. Or just a sequence of numbers. 3, 4, 5, 6, 7, 9. Okay, so now let us say we are trying to find a number 13. Alright, how binary search basically works is it takes the entire number of digits that we have. In this case, we have 9, and it sort of picks a middle number. Okay, 4 on this side, 4 on this side, this is the middle number. So it's going to compare with the middle number. Is 13 equal to 9? No, it's not. Then what it's going to do is it's going to check if 13 is less than 9 or if 13 is greater than 9. Right? I know it's greater than 9 and less than 9. Alright. If 13 is greater than 9, it's going to search the second half of it. If 13 is less than 9, it's going to search the first half of it. But the only requirement for this search is that the numbers have to be arranged first. The numbers have to be in order for this to be able to search very, very quickly. So now that the number is greater than 9, it's going to search this particular set. And the same exact thing it's going to do again. It's going to pick a number in the middle and it's going to compare. Is the number equal or less? In this case, it's less. So it's going to look for the other thing. So in this, then it finds the number. Alright, so that is binary search. I'm going to show you a quick little animation. So that's going to help you a lot. Yeah. So let's just say we have all this set of numbers, right? In this set of numbers, let's just say we want to find out 724. Yeah. So let's just say we're like looking for 724. And let's just, if I say linear search, it just goes and search for it one by one by one. It's very, very inefficient. And it got this. Alright, so instead if I go and say binary search, it's going to see the midpoint of it. It searches the midpoint of it, it just checks again, it checks the midpoint and gets it very, very easily. So within 3 or 4 steps, it was able to kind of like, find the actual value that you're looking for. Alright, so we'll quickly go over sorting again. Sorting, which would be the kind of like the last topic of our discussion. Sorting basically means arranging the items in. Okay. Yeah. So sorting once again is basically, sorting, you understand what is sorting, right? You're going to sort these items in an order. That's the purpose of sorting. So just like in binary search, we might have to kind of like, sort the items first before we kind of like transition into search. So sorting, I'm going very, very quickly, I'm just going to give you an explanation. Just have to look at a couple of problems and you're going to understand it very, very quickly. So in this, let's just say we have this set of items, we have this set of elements, and each element is kind of like represented by a graph or a small bar. So if I say insertion sort, what is it doing? It is taking these two values first, it is comparing these two values. If this value is smaller, it swaps it, then it kind of like goes on a loop of comparing these two values again, then these two values again, then these two values again. If we check now, it's going to compare these two values, this one and this one, such that it kind of like, segregates the smaller things at the bottom. So this is how this insertion sort basically works. What it does is it kind of like, it compares two values, and up until the least value is thrown to the bottom, it's not going to stop. So this value is going to go up until here, because if it finds something that is greater than the value that the value is trying to arrange for, it's not going to stop. Yeah. So as we increase the speed of it, it kind of like, sorts itself. Then let's also quickly talk about bubble sort. We'll decrease the speed, and then we can understand what is happening in this. So what it does is it kind of like, keeps on iterating through the entire set of numbers until no two things have been swapped. Okay, so now it's swapping those two things. Now again it's swapping these two things, and it keeps on swapping. So in this entire round, if it swapped at least once, then it's going to come back again, right? In that way, it's going to kind of like, make sure that nothing is left untouched. If we kind of like, quickly increase the speed of it. So now if in this particular case, there's nothing else to swap, right? So all of these things are arranged in this neat little order. So hence the program is going to stop. Once again, it's kind of like, a very slow and sort of very slow thing that we have. All right. So there is one more small concept at the end of Unit 5, which is the order of complexity, which is the sort of big O notation. So for the order of complexity, what it basically means, the amount of unit time it's going to take for a program to execute. That's the sort of, order of complexity. So for example, let's just say we have a for loop. We have a for loop that kind of, iterates through 5 times, which means each iteration is going to take 1 unit time to execute, which means 5 different times means 5 different units of time. And when we have 2 for loops, it basically means, n square. We're going to take 5 squared units of time to kind of like, execute 2 different for loops. So that's how and so forth. So that's Unit 5. So you just need to understand how to write programs. It's kind of like, comes with a little bit of practice. So once you have the concepts in mind, if you can just write down the algorithms for these particular problems, I think it's going to be very, very simple and very, very easy to write these particular set of programs. All right. So is there anything else that we have to discuss? All right. So let's quickly end the session here, because we have another session coming up in another 10 minutes, which is BW for other branches. So I hope you enjoyed this particular session. If you have found some amount of value in this, I know this was way too long, but this is sort of a subject that we had to discuss through its entirety to basically understand how these things are, because C programming itself is such a subject, without understanding the basic fundamentals of it, we cannot actually go through this entire 4th and 5th units. So if you found this video helpful, please do share this link with your classmates, with your friends, anybody who might need some amount of guidance in terms of C programming. So you have a lot of time in terms of the entire tomorrow to prepare for these subjects. So go over the entire topics. You can find all the topics on Cynohub as well. You can just go over there, you can find all these topics. You can kind of like, study, sit down, practice a little bit more on these topics, and I'm absolutely sure C programming is not going to be that hard, especially once you have these concepts in mind. Alright, so I hope you took away some basic fundamental concepts for C language. I hope this video has been helpful. If it does, once again, like I said, please do leave a like, as well as hit subscribe to the channel. Also make sure your notifications are on as well. And I think with this one, what we'll do is we'll end the stream. But one more thing before you go, what I want to say is, for the upcoming drawing exam, we have another fantastic stream coming in as well. So make sure you're tuned in for drawing as well. We're going to notify you via our YouTube or via the WhatsApp or via Telegram. So do join our Telegram channel. I'm going to leave the link of it in the description. It's t.me/Cynohub. So join the Telegram channel, where we're going to share a lot of important topics. And what I'll also do is I'll share all of these links in Telegram as well. So if you want to kind of like, get a good idea of all the topics that we discussed in this stream, please do join the Telegram channel. And we're going to share a lot of these concepts, a lot of these links there for you to revise. And just a quick note before we leave, Thank you so much for the positive response that we got for this stream as well as the previous streams. We're going to be back for drawing, and I'm going to see you on drawing. I hope you write your exams well. So once again, all the best for your exams, and I'm going to see you for the next stream. All right, thank you. Take care. Bye-bye.